All right, hey y'all, sorry I am not there today, but I was going to do just a few examples here, and then you've got a worksheet that y'all can work together in groups. Since I don't have you guys in front of me, it's tough to know when to stop. So just have Mr. Wood pause it or rewind if something doesn't make sense, okay? So we're looking at section 9.6, which is powers of monomials. And if you remember from before, a monomial is a product of numbers and variables. It can be product or division, but it just can have no addition or subtraction in it. So as long as you've got one term with no addition or subtraction in it, that's a monomial. And we're looking at bringing those to powers. So I'm just going to show you several examples. The first one is, what if we look at x to the second power to the fourth? And the directions to this would just say simplify. All right, I'm going to show you kind of how this works, and then once you know how it works, we can talk through the shortcut. But in general, what does it mean for something to be to the fourth power? It means that that is a factor 4 times. So x squared to the fourth power would mean x squared 4 times. Now this is very different than what we've been doing before, which was like this, x squared times x to the fourth. If you remember that, when you've got a power times a power and the bases are the same, you keep the same base and you add the exponents. So that would be x to the sixth, because this is x 2 times, this is x 4 times, so together that's x 6 times. Your logic would think you would multiply those, but you don't. When you're multiplying, exponents add. So you would be tempted to add these two and think that is x to the sixth, but that's not what's happening. X squared 4 times means x2 4 times, so that would be x as a factor 8 times, because it would be 2 plus 2 plus 2 plus 2. So the rule is, when you have a power to a power, you don't add like when it's a power times a power. When you have a power to a power, you multiply. You distribute this exponent to the exponent on the inside, and it's 4 times 2, which is 8. Okay? So let's look at some more examples. What if it said to simplify 3a to the third power to the second power? Okay, so what that means is 3a to the third is a factor 2 times. So if you think about it the long way, that would be 3a to the third times 3a to the third. Well, multiplication is commutative. Since this is all multiplication, we can move it around in any order we want. So we could write this as 3 times 3 times a to the third times a to the third. 3 times 3 is 9. A to the third, a power times a power. Remember from before, you add. So that would be 9a to the sixth. Well, that's kind of the long way, but you can see how it works. The short way is to distribute the exponent. So you can do that since there's no addition or subtraction. If this had been 3 plus a to the third, you couldn't do this. But that becomes, you distribute the 2 to the 3, so it's 3 to the 2, and a to the third to the 2. Well, 3 to the 2 is 9, and a power to a power, the rule is you multiply. So a to the 3 times 2 is 6. Now, it really doesn't get much harder than that. That's the rule that you apply every time. The only kind of curves that can be thrown is if you have a negative exponent or a negative number. But let's just do a couple more. This, since there's no addition or subtraction, you can just distribute the exponent. That becomes 4 to the third, a to the third, and y squared to the third. 4 to the third is 4 times 4 times 4, which is 64. Power to a power we multiply, so that's a to the 9th. Power to a power we multiply, that's y to the 6th. All right, what if it said this? And the directions would have been simplified for this one as well. Okay, so if it said this, we are going to, since there's no addition or subtraction going on, you can just distribute the exponent. So that becomes m to the negative 3rd to the 5th power and n squared to the 5th power. Power to a power, you multiply. So that's m to the negative 15, n to the 10th, excuse me, which is fine for your final answer, except you can't have negative exponents. So m to the negative 15th, remember a negative exponent just means it's on the wrong side of the fraction. Well, there is no fraction, so you can think of it as over 1, but m to the negative 15 on the top means that if you move it to the bottom, it would be m to the positive 15. Now, n to the 10th is already positive, so it stays on the top, and on the bottom is m to the 15th. There's your final answer. All right, I've got 2 more, and then you guys can be free to work on your classwork homework together. Okay, there's no addition or subtraction going on, so we can just distribute the exponent to every factor. So that becomes negative 3 squared, a to the negative 2 squared, b to the 4th squared, and c squared. Okay, negative 3 squared is negative 3 times negative 3 is 9. A to the negative 2 squared, power to a power you multiply, so that's a to the negative 4. B to the 4th squared, power to a power you multiply, so that's b to the 8th. And c squared stays c squared. And the only thing wrong with this is you've got one negative exponent, so that needs to go to the other side of the fraction. Well, there is no fraction, so make it 1. So a to the negative 4 on the top means that if you moved it to the bottom, it would be a to the positive 4. Everything else is already positive exponent, so it stays on the top, and on the bottom is a to the 4th. All right, last one. Okay, there's no addition or subtraction going on inside, so we can distribute the exponent. That becomes negative 2 to the 3rd, x to the 3rd, y to the negative 3 to the 3rd. Negative 2 to the 3rd is negative 2 times negative 2 times negative 2, which would be negative 8. X to the 3rd stays x to the 3rd. Power to a power you multiply, so y to the negative 3rd to the 3rd becomes y to the negative 9. Okay? The only problem is this negative exponent, so that needs to go to the bottom. Now, negative number is okay. So negative 8 is fine. It's only negative exponents. So negative 8 stays where it is. Y to the negative 9 on the top moves to the bottom. Actually, y the negative 9 when you move to the bottom is y the positive 9. And the only thing left is when you have a negative on the top, positive on the bottom, negative divided by positive makes the whole fraction negative. So that's negative 8x to the 3rd over y to the 9th. That's your final answer. Okay? So your classwork / homework is the 9.6 worksheet. and you should be able to finish that in class today and it not be homework. But if not, it is due Friday. You can work in groups, and I will see you guys Friday.